this section, we are going to learn the law of conservation of momentum, 動量守恆定律. The law of conservation of momentum states that for any collision between two bodies moving along the same straight line, the total momentum before the collision must be equal to the total momentum after the collision. Consider the collision between two bodies 1 and 2. Before the collision, let the velocity of 1 be u1 and that of 2 be u2, and let after the collision, the velocity of 1 is v1 while that of 2 is v2. Let m1 be the mass of the first body and m2 be the mass of the second body. According to the law of conservation of momentum, the total momentum before collision is m1 u1 plus m2 u2, and the total momentum after the collision is m1 v1 plus m2 v2. Since they are equal, therefore we have the equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, and this is the law of conservation of momentum. Let's see how the law of conservation of momentum can be proved by applying Newton's second law and third law. In the above diagram, let's consider the case during collision. Let t be the time duration during impact, and let F1 be the force acting on 1, and let F2 be the force acting on 2 during collision. By Newton's second law, we have F equal to ma. Therefore, we have F1 equal to m1a1 equal to m1 v1 minus u1 over t. And that for 2, we have F2 equal to m2 a2 equal to m2 v2 minus u2 over t. In this case, both time t are the same. By Newton's third law, we have force on 1 and force on 2 are action and reaction pair. Therefore, we have F1 equal to negative F2, which means that the magnitude of F1 and that of F2 are the same. However, they are of opposite direction. Therefore, we have F1 plus F2 equal 0. By adding equation 1 and equation 2 together, we have 0 equal to m1 v1 minus u1 plus m2 v2 minus u2. By simplifying this equation, we get the law of conservation of momentum. This equation is very important in dealing with problems concerning collision. Question number 1. A bowling ball of mass 5.2 kg collides head-on with a pin of mass 1.3 kg. The velocity of the ball before and after collision are 8 meters per second and 7 meters per second. You are asked to find the velocity of the pin just after the collision. But By the law of conservation of momentum, we have m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. We have 5.2 times 8 plus 1.3 times 0, because initially the pin is at rest, therefore u2 equal to 0, equal to 5.2 times 7 plus 1.3 times v2, therefore v2 equal to 4 meters per second. In this case, we know that the velocity of the pin just after collision is 4 meters per second towards the right. Question number 2. Trolleys A and B of mass 1 kg and 2 kg respectively are traveling in opposite directions along the same line with speed 5 meters per second and 1.5 meters per second respectively. If they stick together after the collision, find the common speed of the trolley. By the law of conservation of momentum, we have ma ua plus mb ub equal to ma va plus mb vb. Since they stick together after collision, therefore va and vb are the same, which is equal to v. Since this is the case, therefore we can write ma plus mb times v. The result, we have 1 times 5 plus 2 times negative 1.5, because B is initially traveling to the left, equal to 1 plus 2 times v. Therefore, the common speed after collision will be 0.67 meters per second, which is to the right because this is positive. Now let's consider the case of expulsion of trolleys. Two trolleys A and B are initially pressed against each other by the hands with a compressor spring in between them. When the hands are removed, they move away in opposite direction with speed VA and VB respectively. Before the explosion, the force acting on A and the force acting on B are due to the spring, and they are equal magnitude and opposite direction. Therefore, FA and FB belong to action and reaction pair. Therefore, we have FA plus FB equal to 0. Therefore, the law of conservation of momentum still applies in this case. The total momentum before explosion is ma ua plus mb ub, which is equal to the total momentum after collision mb vb plus ma va. Since the trolleys are initially at rest, therefore ua and ub both equal to 0. We have 0 equal to mb vb plus ma va. That means VB equal to negative MA over MB times VA. The negative sign means that the direction of motion after the explosion of A and B are opposite. Also, the ratio VB over VA equal to negative MA over MB, which means that for a greater mass, the velocity will be smaller. Notice that the total kinetic energy of the theory after the explosion is equal to half MA VA square plus half MB VB square. Where does it come from? Obviously, the total kinetic energy of the theories after explosion must be come from the spring, which is the energy stored by the spring in the form of elastic potential energy. That means the elastic potential energy stored by the spring is now converted to the kinetic energies of the theories. Therefore, they are equal. Similarly, in the recoil of gun, 後褪 recoil means 後褪. When the bullet of mass m1 is fired with a velocity v1, the gun of mass m2 will travel backward, recoil with a speed. The recoil speed is v2. Similarly to the explosion of theories, we have m1 v1 plus m2 v2 equal to 0. That is v1 equal to negative m2 over m1 v2. Since the mass of the bullet m1 is much less than the mass of the gun m2, we have v1, the speed of the bullet will be much higher than the speed of the recoil speed of the gun v2.